Right, we have a polynomial of degree 6 with rational coefficients, and it has these three as zeros, but it's degree 6, so it should have 6 zeros, okay? Now, all this is conjugates. If I have a negative 2 plus 5i, I'm going to have a negative 2 minus 5i as a solution. If I have a negative 2i, I've got a positive 2i, and if I have a 1 minus root 3, I'll have a 1 plus root 3. That's all that is, okay? Now, we're not asking you to multiply all those together, all right? Now, we are going to do, for example, 4 here. Okay, let's have a look at this. Now, let's get the graph in there as well. Okay, a polynomial function, right? It's got negative root 3 as a solution, which means it must have positive root 3 as a solution. Okay, so you've got to figure out what the missing ones are. So this also has positive root 3 as well. Okay, conjugates with the roots and the i's. All right, and then 1 plus I means 1 minus I must be a solution. Okay, so let's maybe do the slightly easy ones first. If I have an x, okay, if I have a negative root 3, it must come from an x plus root 3. Okay. And if I have a positive root 3, it must have come from an x minus root 3. So I'm going to FOIL those two together. Okay. So x times x is x squared. Now, as with conjugates, the outer negative x root 3, inner positive x root 3 will cancel. So finally, at the end, what's negative times positive? It's negative root 3. Root 3 is just 3. That's part of it. There we go. Okay. Now, the slightly harder one. If I have 1 plus I as a 0, it must have come from x minus 1 plus I. Okay. Now look at that. Remember, it was 1 plus I. Because it was positive 1 plus I, it must have come from x minus 1 plus I. All right. If I also have 1 minus I, again the conjugate, this must have come from x. Now again, it's positive 1, so x minus 1 minus I. Okay, now look at that. That's what I now have to multiply together. Again, look at it. So again, 1 plus I, 1 minus I realize were the zeros, so they've come from x minus. Okay, x minus. So how do I multiply these two together? Well, I'm going to show you on another slide. Let's have a look. Different ones. Okay, how do I FOIL, multiply? It's not, you can't really call this FOIL, of course. Distributive law with these two. Well, look. Just take the first part. Forget about the I. Forget about the I term, okay? X minus 2 times x minus 2 equals, right, x squared minus 4x plus 4. Just do a FOIL, okay? That's what it comes out to be. Now then, now just do those two. What's positive 3i times negative 3i? It's negative 9i squared, which will change it to positive 9. Just stick that at the end, okay? So that's how you do it, a quick shortcut, okay? So it's x squared minus 4x plus 13 is the answer to all of that. Again, just do the x minus 2 part, the x minus 2 part, okay? Then do the I bit at the end. So let's have a look at this one. Okay, so x minus 1, I'm going to do the x minus 1 just times the x minus 1. Well, x minus 1 times x minus 1 is x squared minus 2x plus 1. Okay, just do a FOIL with the x minus 1. Now look, I times negative I is negative. I'm just doing the imaginary bit now, just the I bit. I times negative I is negative I squared. You should change that to plus 1. Okay, negative I squared is negative negative 1. So plus 1. So x squared minus 2x plus 2. There it is. Okay. Now you multiply those two together. You know, x squared times x squared times negative 2x, x squared times 2. Then the negative 3 times the x squared, negative 3 times the negative 2x, negative 3 times the 2. You'll end up with this. Okay. Now remember, we know what the intercepts of the zeros were, positive 3 and negative 3. We can't include the imaginary ones. They're not real intercepts, okay? So here we go. Look, over here. Negative 3 and positive 3 with the intercept. Now we found out what this was. So it looks like I had a y-intercept of negative 6. There it is. And that's about as much as we can do with that for now. Okay, but that is you kind of multiplying roots, imaginary numbers, to try and find the polynomial. Okay.